Welcome to Learning Chemistry with the Professor's Du Bois. This is Professor Victoria, and today we're going to learn about isotopes. For simplicity, we are going to say that every atom is made up of protons, neutrons, and electrons. These are referred to as subatomic particles. The protons and neutrons reside in the center of the atom in a very small space called the nucleus, while the electrons reside in a region outside the nucleus. The number of protons identifies the atom. If there are 6 protons in the atom, we can say with certainty that the atom is the element carbon. The number of protons is referred to as the atomic number. This is used to identify the atom and is also the basis for the arrangement of the periodic table. While learning chemistry, you will use the periodic table to find the atomic number or number of protons for each element. Use your periodic table to answer the following questions. Pause the video while you attempt this. The answers to the questions are magnesium for the element that has 12 protons, and there are 3 protons in an element of lithium, or an atom of lithium. Each proton has a charge of positive 1. These positive charges are balanced by the same number of electrons, because each electron has a charge of negative 1. The number of electrons can vary, but when the element is neutral, the number of protons is equal to the number of electrons. If an atom is not neutral, it has a charge and is called an ion. The elemental notation for an ion has the net charge in the upper right of the element symbol. A charged atom or ion can have a positive or negative charge. We will explore ions in more detail in another video. The number of electrons for a neutral atom is the same as the number of protons. Now you can determine the number of electrons for any neutral element from the periodic table, because you know that the number of electrons must equal the number of protons, and the number of protons is the atomic number given on the periodic table. This number is usually the largest number in the cell and increases by 1 left to right. Let's give this a try before moving forward. Pause the video and allow time to answer. The answer is 11. As you can see, the periodic table can be very helpful for identifying the number of protons and electrons in each element. That's a good question. Neutrons do not have a charge, so remember that protons have a charge of positive 1, electrons each have a charge of negative 1, and neutrons have no charge. Great question. The way this is done is by looking at the mass of the atom. The mass of the atom is given in AMU, or atomic mass units. This sounds intimidating, but it's actually a very simple method for indicating the mass. You see, protons, neutrons, and electrons are really small, and their masses in grams are really small. To make things easier for scientists, they set the mass of one proton to 1 AMU. Conveniently, each neutron has nearly the same mass, so they too are 1 AMU. Electrons have mass, but they are so much lighter than a proton or neutron that their mass does not contribute to the overall in a meaningful way. It's like if you weighed yourself before and after you applied deodorant. The layer of deodorant does have mass, but it's negligible compared to the mass of your body. If you are given the mass of a neutral atom in AMU, you can determine the number of neutrons. For example, if I said a sodium atom has a mass of 22 AMU, you can use the atomic number to determine the number of protons. The atomic number for sodium is 11, so there are 11 protons. Each proton weighs 1 AMU, so 11 AMU are present from the protons. Since the total mass is 22, we can subtract the number of protons from the total mass to get the number of neutrons. In this case, the number of neutrons is 11 also. Remember that each proton and neutron weigh 1 AMU. The mass of an electron is so small that it is considered negligible. Let's try a practice problem. Pause the video while you determine the answer. The answer is 5 protons and electrons from the atomic number and 6 neutrons. Remember how I said that the number of protons identifies the element? What I mean is that for a given atom of one specific element, the number of protons is always the same. Every atom of carbon will have 6 protons. The number of neutrons, however, can be different. In fact, if you took a sample of carbon and looked at every atom, you would find many atoms with 6 neutrons, some atoms with 7, and some with 8. An atom of carbon with 6 neutrons would have a total mass of 12 AMU. An atom of carbon with 7 neutrons would have a mass of 13 AMU, and so on. Atoms of the same element with different masses are called isotopes. The element symbol for an isotope must indicate the mass. There are two common methods for indicating the mass of the atom. One way is to write the mass to the right of the element symbol. Using this method, we would indicate a carbon atom with 7 neutrons as C-13. This is called carbon-13. Another method is to write the mass above and to the left of the element symbol. Sometimes the atomic number is written below the mass when using this configuration. Let's try a practice problem and put everything together. Pause the video while you determine the answer. The answer is 1 proton. This is the atomic number of hydrogen found on the periodic table. There's also 1 electron because it is a neutral atom. We know this because there is no charge indicated. The total mass is 3 AMU, and with 1 proton, we can subtract 1 from 3 and get 2 for the number of neutrons. In summary, the term isotope really means that there are atoms of the same element that have differing numbers of neutrons. While isotopes are well understood, it is not expected that you will know which isotopes exist for a given element. You may need to predict which isotope is most common, however. For this, search our other videos for average atomic mass. Thanks for joining us. Be sure to give us a thumbs up if you liked the video, and subscribe if you would like to see more topics on learning chemistry with the Professors Du Bois.